Alright folks, welcome to part 5 of the little Java Spring Boot tutorial. And so in this module, we are going to be discussing Docker. And so what we're going to do is we are going to basically take the baby server that we made in tutorial 1 and throw it in a Docker container and kind of walk through how to build Docker containers and how to run them. So I've gone ahead and created my project directory. We are going to go ahead and open that up. So that'll be here. And we will go to repos, demo 5, open that up. We are again going to be making our basic Spring Boot project. Education. All right, we're going to be using Java 11, right? Packaging jar, type Maven, language Java. Hit next, Spring Boot 270. We shall spin that up. And we need to go to our Palm. And much like all our other projects, we need to add in Spring Boot web. So org.springframework.boot, and then we need Spring Framework starter web, and now we're just going to blow up the version. We are going to update Maven. We are going to come over to our source, to our main, to our Java. We are going to create a new package. We're going to call this controller. We are going to create new Java demo 5 controller. All right. This needs our Rust controller annotation. We need a get mapping. We are going to call this hello. And then we're going to go on string hello, return hello world. Okay. Now, assuming we did all of the things correctly, we should be able to boot up super rudimentary server. That'll say hello to us. All right. Yeah. Ooh, 404. Why not? Because we just called it hello. Okay, so server's working. Perfect. Now, in order to deploy servers to various locations, typically this goes in a very containerized sort of manner. Years ago, the way this used to work is you would use something like, I don't know, Tomcat to run a server on a machine, and then you would build your project, you would get some jars, those jars would be deployed to Tomcat and it would run, and it was kind of a monumentous pain to configure hardware because you need to make sure you would have all your dependencies installed. In today's day and age, we use containerization. Docker and Kubernetes are kind of the most common. Today we're going to be going over Docker. So what exactly does that mean? Well, what that means is rather than having to go to a machine and install Tomcat and copy jars over and all your dependencies, we are going to make a small little container. We are going to install all of our dependencies into that container, and then your hardware just has to run your container. It's a piece of cake. So, first up is you need to have Docker installed. If you don't, go check out my Mac developer setup. It walks through it, but effectively all you need to do is go to Docker's website, download Docker desktop for whatever device you have, and then go ahead and get it running. So assuming you've got Docker set up, we need to create what is called a Docker file. Voila. All right. Now, most Docker files are going to have a handful of very similar components. This is going to be a very rudimentary one, but you can realistically get as crazy as you want with these. So the first step is we're going to need a core operating system, if you will, that is going to run inside of this container. we are going to use just open JDK's Java 11. So to start, we're going to say from open JDK, open JDK 11, and then we are going to use UB1. There we go. All right, second step is we need to set up the environment inside of the Docker container. So that's just env. We're going to say app home is equal to user/app. Right. Then we need to define a working directory. I think it's just workdir. Workdir equals our app home. So app home. So far, so good. And then we need to actually copy the information that comes from our application into the Docker container itself. So we're going to say copy. Whenever we build jar files, they end up in the target directory. So we're going to say copy target star.jar. And we're going to call that app.jar. So I just copies over our jar file into our Docker container. We're going to expose port 8080. So what this does is whenever a REST call goes into port 8080 to the Docker container, we will have to say, okay, Docker container 8080 goes to service 8080, but this exposes the Docker container port 8080 to our host machine. And then we need to have a command, right? So for our command, we are going to be running java-jar app.jar. And that is about as basic a Docker file as I know how to build. Now a handful of things to call out. You could change this command to something like an entry point. You could expose multiple ports. If you had, let's say, like a front-end web service, you would need to copy over more stuff. All the same if you were using like Gradle. This would be, the data you would copy would need to be in a different location. The other thing is you can also use Docker scripts to actually build your application. So the way we're going to do this here in a second is we're going to build the app through Maven, and then we're going to containerize it through Docker. There could be worlds where you want to build your application in a Docker container. For example, let's say that your company used Jenkins to build things out, and you were migrating from Java 11 to Java 17, and their Jenkins box only can run Java 11, right? Rather than trying to update that machine, you could build the app in a container, right? And then take that jar and put that in another container for distribution. If y'all want to see what something like that would look like, I can make one, but this is just to get our feet wet, right? So then the next thing we need to do is we need to open up our terminal, right? And we are going to be working in demo 5 at this point. And we need to go ahead and build our application. So that's just a Maven clean install. Except we actually need to go into the project directory. Okay, so now we have our project built. Now we need to containerize it. And so the way we're going to do this is we go docker build, right? -t to tag it and give it a name. So we're going to call this demo 5 docker, right? We'll give it a version number of 1. And then we go period. This period just indicates the Docker file is in fact in the same directory we are working on. So hit enter. Let's see, failed to solve front-end docker v.o. Huh. Oh. Really? Really, Jacob? Really? Alright, so I ended up putting the Docker file at the root. It actually needs to be in demo 5. So we're going to stick it there. Refactor. Alright, take 2. Boop. Alright. Error. Okay. Load metadata for Docker IO.openjdk JDK11. Okay, so it looks like I probably fat fingered something up here. So we have adopt open JDK. That should be open JDK11. And that should be just colon UB, UB1. All right, third time's a charm. There we go. All right, so at this point, we are now downloading all of the open JDK 11 things that we need and building our container. All right, cool. So now for our next step is running this container. So in a perfect world, if you were to work at a company that had a DevOps department, you would build your container and you would upload this container to a repository somewhere. And then as far as deployment goes, they would pull down that container and start it on whatever machine. We don't have any sort of repository set up other than what we have locally, so we are just going to run this Docker container locally. So the way we do that is docker run -d, and then we're going to look it up by its name, which we named it demo 5 docker, right? -p exposes ports, so we are going to forward port 8080 on my local to port 8080 on Docker, and then we need to tell it what we're actually running. So demo 5 docker version 1. And then so this spins up a Docker container. If we were curious, we could run docker ps, right? This shows that the container ID in the image is running. It's been up for about 4 seconds. So then if we go to Postman, and keep in mind, we don't have anything running in our IDE, right? Nothing's running anywhere other than this Docker container. We can go localhost 8080 hello, press send, and we get hello world back, right? This is coming from this little containerized piece of code, right? And then if we want to, we can go docker kill container ID, right? And then we will no longer have it running. And then if we come over back to Postman, no response. And so that's kind of the down and dirty on how to dockerize a Spring Boot application. And again, these can get as complex as you want them, but this is a real simple version. And that's really all there is to it. For more reading, I would highly suggest checking out Docker's website. And figuring out, I guess, what some different paradigms look like. Something else, I guess, to be aware of is if you were ever doing local development and you were trying to get a piece of infrastructure on your local to test against, right? In demo 4, we used H2, which is an in-memory database, but let's say you wanted to play around with a memory cache, something like Redis. You would need Redis installed on your local. You could either install Redis and potentially have some headaches there, or you could just pull down a Docker container and run Redis in a container. And then whenever you no longer need Redis on your local, you just blow out the container and you don't worry about it. So Docker can be super handy for both deployments and running code locally. But those will be, I guess, videos for another day if y'all are interested. And with that all being said, that concludes Demo 5. Thank you.